Hello everyone, this is Amit Umakant Dwivedi, Professor at Utthan, Shambunath Institution, Prayagraj. I am also the member of UK Educational Trust and U.K.Academy of Science and Commerce. We already made an introductory video about UK Educational Trust about what we are and what we do. Our collective aim to ensure that every child in this nation have the opportunity to receive an outstanding and excellent education. So I hereby welcome you all in this session. Today we are going to discuss about the syllabus of Doctor of Pharmacy program first year provided by the AKTU, the APJ Abdul Kalam Technical University, Lucknow. So this is the syllabus which is provided by AKTU, and the syllabus is not described here properly, so we'll see the syllabus one by one, and in this session, in this series of lectures, we'll be covering all the topics one by one. So let's continue the discussion of this syllabus of Pharm.D first year AKTU University. Okay. And the first topic which is given by AKTU is algebra. And this we have determinant and matrices, and we cannot see here that which topic of determinant and which topic of matrices will be covered here and should be covered here. So today we'll see all the topics one by one, and we'll discuss about the explanatory syllabus of the topics. Okay, and as you can see here, first point is the algebra, in which the points are matrices and determinant. In the matrix part we have some point, then in the determinant part we have some. Okay, in the matrix part we have first we'll be seeing first a determinant of matrices and the representation of a matrix, how you represent of a matrix, how you write a matrix, then order of a matrix and position of an element of the matrix. Then we have some types of matrix in which we will be seeing the zero matrix, then row matrix, then column matrix, then triangular, diagonal, symmetric, skew symmetric, and so on. Okay, so the next point is algebra of matrices. In the algebra of matrices, we will be looking at how to add two matrices, how to multiply a number, a scalar in a matrix, how to subtract, how to multiply two matrix, and then how to divide. And we don't have how to divide here, but we'll be looking at the inverse matrices, because if we say that A by B, we'll be looking at A into B inverse. We'll see the definition of invertible matrix, and then we'll be looking at these type of things. Okay, so the next point we have is elementary operations here. Elementary operation, in which we will be looking at the elementary row operation ERO and elementary column operation ECOs. They both look similar. Okay, then we'll using the ERO to represent the matrix in row echelon form. We'll be seeing that what is row echelon form and what is reduced row echelon form. Okay, then we'll see the rank of a matrix, in which we'll be looking at two types of rank. One is row rank and then column rank, and we'll be looking at the property that row rank of a matrix equals to column rank of a matrix equals to the rank of the matrix. Okay, and then the next thing is, as I have already said, that we will be discussing the invertible matrices, and then we'll find the inverse using elementary operations. Okay, EROs. Then we will see the application of matrix in solving system of linear equation, system of M linear equation with n unknowns, and so on. And next point here we have the determinant of matrix, and we'll be looking at the determinant of a matrix of order 2 and order 3. So determinant is nothing but the operation on the matrix, and we'll be looking at the determinant of matrix of order 2 and matrix of order 3, in which we'll be looking at only square matrices. Okay. Now next is we have the properties of determinant, and we'll use the property to find the value of determinant. Okay. The minors and cofactor, and then we have adjoint matrix, which is called as ADJ of A. Very cool name, ADJ of A. Okay. Now next thing is we have finding the inverse of a matrix using adjoint matrix, or you can say it is called as adjoint method of finding the inverse. Okay. Now again we have some application of the determinant, which is called as Cramer's rule of solving the system of linear equation. Here we will be looking at the system in which the number of equations equals to number of unknowns. Okay. Okay. Now next point we have is trigonometry, in which we will be looking at the angles, we will be looking at the Cartesian coordinate system, in which we have 4 quadrants, and then we will see measurement of angles. Then we are looking at the types of angle here, and next point will be the trigonometric ratios and trigonometric functions, and trigonometric identities and equations. We can say some formulas of some properties on the trigonometric ratios. Okay. Then we will look at the signs of trigonometric functions, trigonometric ratios and compound angles. Here the spelling mistake is there. It is trigonometric. Trigonometric, okay, trigonometric, here also trigonometric. We will see the trigonometric ratios of compound angles and trigonometric ratios of half angles. Okay. Okay. Now next point here it will be the analytical geometry, in which we will be looking at 3 types of shapes, 3 types of things here. So first we will be looking at the system of coordinates in analytical geometry, and in system of coordinates we will be looking at the Cartesian coordinate system of representation, 2-dimensional as well as 3-dimensional. We have to use the only 2-dimensional thing, but we will also see the 3-dimensional Cartesian coordinate system. Okay. Now then we have Cartesian coordinate, then we have the distance between 2 points, which is called as distance formula. Okay. Then we have collinear points. We will see the given 3 points are collinear or not using the distance formula. Okay. And next point we have is section formula and midpoint formula, and then the area of triangles. And the last point in this system of coordinates is locus and equation to a locus. Okay. Next thing in this analytical geometry is called as the straight lines. In the straight line we will be looking at the slope of line joining 2 points, and we will be looking at the slope using the angle subtended by positive direction of x axis to line in anti-clockwise direction. Okay. And next is equation of lines, in which we have some forms, some types of representation of equations we have, and in which we have 2-point form, 1-point slope form, slope intercept form, and double intercept form. Okay. The last point in the analytical geometry is nothing but the circle and the parabola. In the circle we will see the definition of circle, the properties of circle, and we will solve some more problems, as well as same thing in the parabola. Okay. The next point in our syllabus is this is 2, okay, this is 3, the third point in analytical geometry, and this is the fourth point of in the syllabus. Okay. The fourth point is differential calculus, and to learn the differential calculus we should have some preliminary information and knowledge about set theory, relation and function. Without set theory, relation and function we cannot understand the differential calculus, we cannot understand the limit of function, you can say, because this is function and we are finding the limit of it. So first of all you have to know function, what is the function. Okay. So in that the first point is preliminary knowledge of set, relation and function, and next we will be discussing about the limit of function. In the limit of function, we will be seeing the definition of limit, we will see the geometric understanding of limit. What do you mean by limit? We will see using geometry, we will using the graph of the function. Okay. Next is we have some algebra of limit and then properties. In algebra of limit, we will be discussing about the limit of sum function, limit of product function, limit of you can say difference function, composite function, and you can say quotient function. Okay. And then we have continuous functions, or you can say continuity of a function. So, we will be looking at here at definition of the continuous function, algebra of continuous function again, and some properties of continuous functions. Okay. Next point, the differentiability, the major point in differential calculus, differentiability of a function. We will see the definition of derivative. What do you mean by derivative using geometry, using the graph of function? Okay. And then we will be defining the derivative of the function using the left hand derivative and right hand derivative of the function. Okay. The differentiability and continuity theorem we will be looking at. It states that the function is differentiable, then the function is continuous at given point. Okay. So, we will be looking at this theorem, and what do we mean by this theorem? We will be looking at that. Okay. Next point we have is finding the derivative. By mistakenly here written as different determinant, but this is finding the derivative. Okay, finding the derivative using first principle, means using the limit definition of derivative. Okay. Now, derivative of explicit functions we will be looking at, logarithmic differentiation we will be looking at, and then parametric differentiation. And also we will be looking at the successive differentiation and Leibniz theorem. And the last point in differential calculus is nothing but the partial derivatives. Okay. The partial derivative mostly defined for the functions having more than one variable, more than two variable, you can say. Okay. The next point we have in our syllabus is integral calculus, and in integral calculus there are two types of integrations. One is definite integration, one is indefinite integration. We will be looking at in the definite integration the integration by parts, finding the value of integration by parts method, and finding the value of integration by substitution method. Okay. Now, next point we have indefinite integrals, and we will be looking at its properties. There are some properties of indefinite integrals. Okay. Now, the last point, the second last point in the syllabus, the sixth point in the syllabus is differential equations, and in the differential equation we will be looking at the definition of differential equation, the order and degree of differential equation, and we will be looking at the examples of differential equation of first order and first degree and the solution of same. Okay. And then we will be looking at the solution of first order and first degree differential equation using the variable separable form first one, and then we will be seeing the linear differential equation. Also we will be seeing here the homogeneous differential equation. Next, homogeneous differential equation of first order and first degree, homogeneous differential equation. Differential equations. Okay. The homogeneous differential equation of first order and first degree, and then we will be solving the second order homogeneous differential equation and non-homogeneous differential equation using or having the constant coefficients. Okay. These 2 points we have here. Already I have written here the homogeneous differential equation, again I have written the homogeneous differential equation again. Okay. So, now the next point is the linear equation of second order here, the linear equation of second order. Okay. And the last point in the syllabus is Laplace transform. We will be looking at the definition obviously, and the existence and uniqueness property, sufficient condition of existence of Laplace transform, and then we will be looking at the Laplace transform of some elementary functions like trigonometric functions, algebraic functions, logarithmic functions, and so on. Okay. Then we will see the property of determinant, in which we will be seeing the two properties. First is linearity property and next is shifting property. Okay, that was the syllabus. So, I hereby welcome you all. We will be looking at each and every point in the syllabus one by one. Okay, so I stop myself. Thank you so much.